In this video, I want to show you how to create a full plate dome by mapping a 3D object onto a surface. Um, we call this action of mapping a 3D object, a 3D shape onto a surface, morphing. And we're going to do that um, on that semi-spherical surface we earlier created. So we have our semi-spherical form, and I want to create a pyramid shape as the module that I want to morph it onto that surface. So I get started with defining the base rectangle. And then I use extrude to point. And then the point will be height. Oh, I should define an X, Y, Z point. X, Y, Z point. This is the Z point. And since I want to make sure that this is a pyramid shape, the X and Y coordinates should be in the middle of this rectangle. So I will use division to get this X coordinate. And I will connect it to X. And then this is easier to just track. And then I will do the same thing for the Y. This is right in the middle, and then I will connect this Z coordinate. And then I will connect this point. You can also drop a point into Rhino canvas, but this is not a good habit because then it will be disconnected. This point will be disconnected from your rectangular shape. Now this is the boulder plate module. To change the color. There. There is a component in Grasshopper. It is called Box Morph. This is it. It asks for the geometry. Do you want to morph it, and then a reference box. So that reference box is actually the bounding box that bound this geometry in it. There is a component in Launchbox, which is called a bounding box. But here, without using any additional plugin, you can create that box. And since we actually use extrude to point, and we have the rectangular base and the height, which is that Z coordinate, we can simply get the bounding box and connect it to the reference. So Grasshopper should take this bounding box and map it and twist it and distort it in a way that it gets fit into a distorted box on this surface. To create a pattern, or let's say to split the surface into a series of boxes, you need to use the surface box. Surface box. There we go. You create a twisted box on a surface patch. So you say this is the surface, and you need to divide the domain, domain squared, because you want to say what are the number of segments along the U and V direction. Also, earlier I told you that these directions U and V doesn't necessarily mean along X and Y. Sometimes it's radial and meridional. So I will say this is the domain, and I want to split it into, for example, 1 to 50. And I can also give a height. So this thickness it can vary. So I would say something between 1 again and 20. So this is the height. I can play around with that height. And this is the target. So when I do that, let's just turn this off. You'll get this kind of porcupine pattern. So this script show you how to morph a 3D object onto a surface, but we're still away from the form I initially showed at the beginning of this video, which was this. The reason that we're getting a different way of morphing those pyramid shapes is that the way that we splitted that spherical surface. So in that regard, the U direction, like the first direction, is along the meridional direction. So if I want to change that, I can say this division is 1, this is 2, and then the dome will be in this shape. And you can just simply rotate the initial sphere and say, okay, this is the geometry. And the angle by default is a half of pi. I would say I would say negative half of pi to make sure that I'm getting the right dome. And then the plane, I want to rotate this dome in this direction, clockwise in this direction. So it will be X Z plane. So here we go. Now, instead of connecting that dome, I will connect the rotated sphere, the same spherical form. There we go. So this is related to the sphere. This is related to create a twisted box. I'm just reorganizing housekeeping. Creating the twisted boxes. There's one other thing that might be fun to explore, and that is scaling the stone. So we have used scale component before, but you can also use scale as a with non-uniform factors. When you scale, for example, with a factor of 2, the whole geometry will be scaled in all directions with factor of 2. But here you can say, I want this geometry be scaled with different factors. So I can say with a factor of 1, 2, for example, 5. Change it a little bit. Move on. So just to show you what would happen, then you can play around with this scale factor. You can like kind of create a more low-rise dome. And again, this time, instead of connecting that geometry, I'm going to connect this geometry. And you can see the effect of Let's just turn this off. The effective using the non-uniform scale. And you can create like high-rise domes or low-rise domes with any particular factor. Yes, that's all. Enjoy playing around with your folded Play-Doh.